Drones, or unmanned aerial vehicles, UAVs, are fundamentally reshaping the landscape of modern warfare, transforming everything from strategic military planning to frontline combat operations. Once viewed merely as surveillance tools, drones have rapidly evolved into critical combat assets capable of executing high-risk missions without endangering human pilots. Their ability to remain airborne for extended periods, fly at varying altitudes, and transmit real-time intelligence has made them indispensable in both low-intensity conflicts and high-tech battlefield environments. From the deserts of the Middle East to the contested airspace over Eastern Europe, drones are now routinely deployed for intelligence gathering, target acquisition, airstrikes, electronic warfare, and even cyber operations. Their cost-effectiveness, compared to manned aircraft, has also democratized air power, enabling smaller nations and even non-state actors to project force and conduct precise operations once limited to superpowers. This affordability, paired with technological advancements in autonomy and artificial intelligence, has opened the door to swarms of coordinated drones capable of overwhelming enemy defenses, jamming communication networks, and disabling key infrastructure with surgical precision. Warfare is no longer bound by traditional rules of engagement. A drone operator stationed thousands of miles away can now strike a target in real time based on satellite data, thermal imaging, or AI-driven threat detection. This has accelerated the pace of warfare, reduced the decision-making window, and blurred the line between combat zones and civilian spaces. In asymmetric conflicts, drones offer governments a strategic advantage by allowing persistent surveillance over hostile terrain, aiding in counterterrorism operations without committing ground troops. In large-scale wars, such as in Ukraine, drones have been used to devastating effect for artillery correction, anti-tank missions, and even kamikaze-style attacks. Nations like the United States, China, Israel, Turkey, and Russia are not only deploying drones, but also rapidly investing in next-generation autonomous systems that can act independently, operate in swarms, or even mimic manned aircraft formations. Moreover, drones are becoming vital in non-combat roles, such as delivering medical supplies in conflict zones, performing search and rescue missions, or restoring communication networks after infrastructure damage. However, this technological leap also introduces new challenges. The rise of drone warfare has sparked urgent debates about international law, accountability in automated strikes, and the ethical implications of machines deciding life and death. As AI grows more sophisticated, so too do the possibilities and dangers of autonomous combat systems. Rogue states or terrorist organizations can now access commercially available drones and modify them for malicious purposes, posing a growing threat to both military and civilian infrastructure. In essence, drones have redefined the scope, speed, and structure of modern warfare. They offer military forces unprecedented reach, flexibility, and precision, enabling them to strike first, strike fast, and strike deep, with little warning. As their capabilities continue to expand through AI integration, stealth technologies, and improved communication systems, drones are set to become the centerpiece of future military doctrine. This marks not just an evolution in tools of war, but a revolution in how wars are fought, won, and even deterred. In the coming decades, the nation that masters drone warfare may hold the key not just to victory on the battlefield, but to global strategic dominance. Counter-uncrewed aerial systems, CUAS, are specifically designed to detect, track, and neutralize UAVs. This can be achieved through detection systems, radar, electro-optical infrared sensors, and acoustic sensors that identify UAVs in the airspace. Jamming devices, portable or fixed. Missile weapons, anti-missile systems, air-to-air weapons. Kinetic weapons, shotguns, anti-air machine guns and cannons. Directed energy weapons, high-energy lasers or microwave beams can disable UAVs by damaging their electronics or propulsion systems. Nets and drone-on-drone technologies, physically intercepting or capturing UAVs. Disrupting or neutralizing any links relied on by the UAS, such as launch and recovery units, ground control stations, communications equipment, logistics, and supporting systems, can significantly hinder the UAS's operational capabilities. The proliferation of cheap, expendable, Class Y drones has created an unfavorable interception curve for traditional air defense platforms. Larger drones with a distinct radar cross-section are easy, slow-moving targets for air defense interceptors and artillery, while traditional air defense has some limitations against small systems. An emerging challenge of counter-drone defense is its cost-effectiveness, where the counter-drone system must be cheaper than its target. Greater investments in EW will be a key part of any counter against the threat of drones. The financial imperatives of using drones are compelling. They offer cheaper alternatives to traditional military systems, creating cost imposition strategies that can burden adversaries financially. In a long and large conflict, cost is key. The fewer resources used to destroy a target, the better. Defeating a $500 drone with a 3 MBAR missiles may be effective, but not sustainable. As quantity matters, the more drones a state can produce, the more sustainable its drone operations, and the more credible its threat to stay the course. UAVs provide cost-effective alternatives to traditional military systems, offering significant financial benefits. They impose financial burdens on adversaries by requiring them to use expensive countermeasures against inexpensive drones. This cost imposition strategy is critical in modern warfare, where financial constraints play a significant role in the longer term. The cost-effectiveness of these systems underscores their importance in contemporary and future conflicts. Ukraine has demonstrated the effective use of innovation due to necessity, adapting to survive by leveraging new capabilities. When considering the cost of acquisition and transportability of these drone systems, it becomes clear why it is important for countries like Australia to stay abreast of emerging threats and opportunities. Land drones or unmanned ground vehicles, UGV, ground robots, could be the next frontier in military innovation. In Ukraine, these vehicles have already been operating on the front lines for over a year to carry weapons and explosives, to conduct remote mining and demining, and to evacuate wounded soldiers from the battlefield. The main purpose of these UGVs has been to minimize participation of the Ukrainian forces on the battlefield, helping to preserve lives of Ukrainian soldiers. Use of UGVs is an asymmetric response to the enemy's numerical advantage. These UGVs have performed tasks such as remotely mining positions and choke points, protecting fiercely contested areas with automatic weapons, and using anti-tank equipment against heavy vehicles, which have also been found vulnerable to UAV drones. UGV development has also focused on logistic and casualty evacuation roles. For example, a multifunctional robot Vepr, KNLR-E, codified to NATO standards, has shown positive outcomes of its use since 2023, see Figure 4. According to the Minister of Digital Transformations of Ukraine, Ukraine starts mass production of robotic ground platforms.